Hi, hello friends. So today in the learning series of statistics, we will discuss the remaining topic for the last from the last session. So we'll continue this series until finish some of the important concepts which will be helpful in the code when we develop our project. So this is in this series in the previous series we completed that type of statistics. There is two type of statistics, always remember: descriptive statistics and inferential statistics. Okay, so when you remember the type of statistics, that is descriptive statistics and inferential statistics. Now if we elaborate descriptive statistics, that will be measured through measure of central tendency, measure of central tendency having mean, median, mode, okay, and measure of variance having range, variance, and standard deviation. Okay, so in the last series we discussed about range, variance, and standard deviation. Now we'll discuss about variance a lot more. So what variance can do in this statistics module? So statistics module provides very powerful tools which can be used to compute anything related to statistics. Okay, so these are the statistic module. Some of the statistic module will help, and these are the powerful tool that will be easy to communicate when we try to communicate with something. Compute, so not communicate, compute the calculation of any tabular data or representational data. So or RDBMS or DBMS. So we this is variance method is one of such function. This function helps to calculate the variance from a sample of data. Sample, what is sample? Sample is subset of populated data. So whatever the data you have, those variance function will help us to calculate this sample data. So variance function should only be used when variance of a sample needs to be calculated. There is another function known as variance, p-variance, which is used to calculate the variance of entire population. There is variance and p-variance, difference between these two. You must remember these definitions. If we talk about in pure statistics, the variance is square deviation of the variable in its mean. So in the previous classes, I also told you what is variance. So variance is a squared of mean variable, square deviation of the mean variable. Basically, it measures the spread of random data in a set from its mean or median value. A low value for variance indicates that the data are clustered together. A low variance, whenever we find a low variance from our tabular data, when we find mean and square the deviation, so we'll find variance, and then when we find variance, then it generates low value. If it comes low value, that will indicate the data are clustered together, and are not spread apart widely. So you know the clustered meaning, that are not spread apart. Whereas a high value would indicate that the data in the given set are much more spread apart from the bridge value. So this is how we talk about. So for a low value, for variance indicates the data are clustered together, not separate apart. Whereas a high value would indicate that the data in the given set are much more spread apart from the average value. So high value variance will indicate the data are separate and spread apart. Variance is an important tool in sciences. So where statistical analysis of data is common, it is square of standard deviation of the given data set, and is also known as second central moment of distribution. It is usually represented by in pure statistics. Variance is calculated by following formula. It's calculated by mean of square minus the square of mean. Okay, that means calculated by mean of square minus square of mean. So variance formula is mean of square minus square of mean. So this is how variance will be calculated. So variance of data or x bar. Variance of data is iterable with real valued numbers, or x bar optional takes the actual mean of the data set as the value. Return type returns the actual variance of the values passed as a parameter. Exception, statistical error is raised for data set less than two values passed as a parameter. Throws impossible values when the value provided as x bar doesn't match the actual mean of data set. So this is how it explains. We have some code blocks, so we'll import statistics. We already did it, and the sample will create the sample of data is created. Now the variance we want to create, so print variance of the sample set. So how variance will calculate it? We'll use the variance function. Variance function will calculate the sample data. This sample data is created. Now variance will be calculated. This will be automatically generate the output. You do not require to do calculation with your own. So this is the predefined libraries we have to calculate the variance in the Python. Demonstrate variance on the range of data types. So now data types will be separate. So this is the statistic, very important variances. So this is already variances provided over here. Previously not there. So variance is there. From fractions, import fraction as fr. Sample is there. Okay, then integer value is there. Tuple of positive integers, negative integers there. Positive and negative both integers are there, and the fractional numbers are there, and the floating point numbers are there. So how sample 1, sample 2, 3, 4, 5 is calculated. This is how, and this will be output through percentage s. So previously also it will shows displayed through this variance will always return in percentages, always remember. So variance will always remember the percentage s. Okay. We have certain demonstration in x bar parameter also in use of. So we'll use the import statistics file. We have sample list. We have mean of the sample list. So mean will calculate like this. Status dot mean function value of sample value will be created, put it over here. So this is how mean is. We got the mean. Now sample x bar, variance for sample x bar. So this will return variance of sample set. Okay. X bar parameter. So demonstrate the error when value of x bar is not same as the mean average value. Python code to demonstrate the error caused when garbage value of x bar is entered. Import statistics sample m statistics dot mean sample. Oh, so now we'll okay. We'll the next is x bar not as the same mean and average. So the import static sample is there, statistic mean sample is available, and the variance of x bar, which is -100 as the value for x bar parameter. So this is how this value will be given to their questions also. So the output will be this. Demonstrate statistic error. So what is the statistic error? Sample is created, no data is there, so it will throw a track back. This is like line number 10. It is not these errors. Applications variance is very important tool in statistics and handling huge amount of data. Like when the omniscient mean is unknown or sample mean, that then variance is used as biased estimator. Real world observations like the value of increase and decrease of all shares of a company throughout the day cannot be all set of possible observation. As such, variance is calculated from a finite set of data, although it won't be matched when calculated taking the whole population into consideration, but still it will be give the user an estimate which is enough to chalk out other calculations. Python normal distribution statistics. This is Python normal distribution. Now we discuss variance. So in the continuous series, I started with statistics. The two types of statistics: descriptive statistics and inferential statistics. We discussed this differential statistics. Descriptive statistics like measure of central tendency, and this measure of variances. measure of central tendency, mean median mode, measure of variability, range, variance, standard deviation. So we all discussed all three, and now variances again we discussed, and now we have normal distribution. This is a different topic from this, but we left with inferential statistics. So this is the part. So we like this is Skippy. This is Skippy. Skippy states dot norm function is normal continuous random variable. This is normal. This is normal continuous random variable provided. It inherits from the generic method. It will inherit from the generic method of an instance of the RV continuous class. It completes the method with the details specific for this particular distribution. So parameters provided lower and upper tail probability and X is quantities. IOC is optional location parameter default. Scale is optional scale parameter default 1. Size tuple of ints optional shape or random variates. Okay. Now moments is there optional opposed composed of letters. MVSK mean variances Fisher's Q and K is Fisher's kurtosis. So this default MV is also there. Now will these are the parameters. So you always remember Q where Q lower and upper tail probability, X is quantile, and IOC is location parameter, scale parameter, shape or random variates. This is composed of letters movements. So this is M for mean variance, Fisher's Q, also Fisher's kurtosis. So normal continuous random variable, how we will calculate? We'll describe the library like Skippy or Skippy as in Skippy dot state. We can say like we can like vocab like we're using vocabulary Skippy we can use. So from Skippy dot states import from norm. Now number argument is provide norm dot this norm dot number argument. Now this A B is having the value the norms argument. Okay, in the norms. So this RV is provided. Now the output will be there RV for RV. So RV is like calculated. RV is for as I told you, RV is for their represented RV continuous class. So this is RV how it's calculated. And we have normal continuous varieties and probability distribution. So we'll import a numpy and as NP. So quantile will be there, NP dot arrange is values there, and norm dot this norm dot RVS AB is printed on to R, and norm dot PDF. So AB quantile is also available. So this will be printed also. Graphical representations over here. Import numpy as an NP and import matplotlib dot pip lot as PLT. Distribution is available NP, this NP dot line space, and this is line space is available over here. How the parameter is NP dot minimum. So this is how the output will be created. So this is how the output of this value, this float is measuring the distribution of this. This is the graphical representation of plot. So varying positional argument, import matplotlib dot flipplot pyplot as PLT. This is numpy as numpy NP, and NP dot line space. This is line space is provided over here, and varying positional argument. So this is how one by one norm dot PDF x135. So this is how it generates the output. Okay, so this is how the varying positional argument line spaces will be created for NP, and this p plot as the p plot is plt plot dot plot value x value is there, y1 value is there. Then this is the rearrangement of this x and y different to where this r minus 1 is also available. So this is how it's represented now. So in this video we discussed about the variances and this distribution in statistics, normal distribution in statistics. Now in the next video we'll talk more into statistics. Till then, thank you, and please like my videos, comment on my videos, ask some question, but I'll reply your all your question. If you have any doubts, or you have any suggestions for my videos, and some suggestions for this session as well. If you have any suggestion for this session, so you can also suggest me something, like how we did something less explanation over there, or something is missing in this. So you can message me in also, and please subscribe my channel also, and share with your friends, which this free learning session will be easily helpful to everyone. Thank you and bye.